The National Electrical Code Article 695 addresses fire pumps. Specifically, Section 695.3b covers the power supply requirements. Paragraph 2 pertains to electric motors and includes two subsections regarding transformers. Firstly, separate transformer. Where a single transformer supplies both the fire pump and other loads, the transformer must be provided with primary and secondary overcurrent protective devices that are coordinated to isolate the transformer from any fault on the fire pump feeder or the other loads served by the transformer. Secondly, separate circuit. Where two or more transformers supply both the fire pump and other loads, each transformer must be provided with primary and secondary overcurrent protective devices that are coordinated to isolate the transformer from any fault on the fire pump feeder or the other loads served by the transformer. However, there is an exception. Where the transformers are connected in a network or parallel arrangement and have adequate overcurrent protection in the primary and secondary circuits to limit the fault current to a value that will not damage the transformer, separate overcurrent protective devices for each transformer are not required. Interpreting this, the NEC effectively mandates a separate transformer for fire pumps if the existing transformer cannot adequately handle the additional load while simultaneously safeguarding the fire pump from faults originating from other building loads. The primary aim is to guarantee the fire pump possesses a dependable and autonomous power source during emergencies. Conversely, if the existing transformer possesses the capacity to safely manage the augmented load and is equipped with appropriate fault protection measures, a separate transformer might not be a mandatory requirement. This determination is contingent upon a thorough assessment conducted by a qualified electrical engineer, taking into account the specific building design and electrical system characteristics. It is paramount to engage a qualified electrical engineer to conduct a comprehensive evaluation of the existing electrical system to ascertain whether a dedicated transformer is indispensable for the fire pump. The engineer's expertise will facilitate a meticulous analysis, culminating in well-informed recommendations that ensure adherence to the NEC stipulations and alignment with the owner's objectives. The engineer would consider several factors. Firstly, the existing transformer's capacity. The engineer will determine if the current transformer is adequately sized to handle both the building's normal load and the additional load of the 125 horsepower fire pump. This involves calculating the total connected load and comparing it to the transformer's nameplate rating, while also considering any diversity factors that might apply. Secondly, overcurrent protection coordination. The engineer will analyze the existing overcurrent protection devices, such as circuit breakers and fuses, to ensure they are properly coordinated. This means that a fault on the fire pump feeder or any other building load should be isolated without causing a complete shutdown of the electrical system. The coordination study will verify that the overcurrent devices are sized and set to trip in a specific sequence, minimizing the impact of faults. Thirdly, fault current analysis. A fault current study will be performed to determine the magnitude of fault current that could flow in the electrical system under various fault conditions. This analysis will help determine if the existing transformer and overcurrent protection devices can withstand the available fault current. If the fault current exceeds the equipment's rating, upgrades or modifications might be necessary. Fourthly, compliance with NEC Article 695. The engineer will thoroughly review NEC Article 695 to ensure that the fire pump installation complies with all applicable requirements. This includes verifying that the fire pump has a reliable and independent power source, that the overcurrent protection devices are properly coordinated, and that the wiring methods and equipment are suitable for fire pump applications. Fifthly, voltage drop calculations. The engineer will perform voltage drop calculations to ensure that the voltage at the fire pump motor terminals remains within acceptable limits under both starting and running conditions. Excessive voltage drop can cause the motor to overheat and fail, so it's important to ensure that the wiring and transformer are adequately sized to minimize voltage drop. Sixthly, reliability and redundancy. The engineer will consider the overall reliability and redundancy of the electrical system. If the existing transformer is critical to the building's operation, a separate transformer for the fire pump might be recommended to provide a backup power source in case of a transformer failure. Seventhly, cost-benefit analysis. The engineer will perform a cost-benefit analysis to compare the cost of installing a separate transformer to the cost of upgrading the existing transformer and overcurrent protection devices. This analysis will help the owner make an informed decision based on both technical and economic factors. Eighthly, coordination with the power company. The engineer will coordinate with the local power company to ensure that the proposed fire pump installation meets their requirements. This includes verifying that the power company has sufficient capacity to supply the fire pump and that the installation complies with their interconnection standards. Ninthly, documentation and approvals. The engineer will prepare detailed drawings and specifications for the fire pump installation and submit them to the local authorities for approval. This will ensure that the installation complies with all applicable codes and regulations. Tenthly, future expansion. The engineer will consider the possibility of future expansion of the building's electrical system. If the building is likely to grow in the future, a separate transformer for the fire pump might be a more cost-effective solution in the long run. The NEC does not explicitly mandate a separate transformer for fire pumps in all scenarios. The primary concern is ensuring a reliable power supply to the fire pump during an emergency. The key is that the transformer and associated overcurrent protection must be coordinated to isolate any fault on the fire pump feeder or other loads. If a single transformer is used for both the fire pump and other loads, the overcurrent protection must be carefully coordinated to prevent a fault in the building's electrical system from shutting down the fire pump. If the existing transformer's capacity is sufficient to handle the fire pump's load without compromising the building's normal operations, and if proper overcurrent protection coordination can be achieved, a separate transformer may not be required. The exception in NEC 695.3b2 allows for the use of transformers connected in a network or parallel arrangement, provided they have adequate overcurrent protection to limit fault current. In such cases, separate overcurrent protective devices for each transformer are not necessary. This arrangement typically involves sophisticated protection schemes and is more common in larger facilities with complex electrical distribution systems. The decision to use a separate transformer often depends on a variety of factors, including firstly, the size of the fire pump. Larger fire pumps require more power, which may exceed the capacity of the existing transformer. Secondly, the existing electrical load. If the building already has a high electrical load, adding a fire pump to the same transformer may overload it. Thirdly, the age and condition of the existing transformer. Older transformers may not be able to handle the additional load or may not have the necessary overcurrent protection. Fourthly, the cost of upgrading the existing transformer versus installing a new one. In some cases, it may be more cost-effective to install a new transformer specifically for the fire pump. Fifthly, local codes and regulations. Some local jurisdictions may have stricter requirements for fire pump installations, including the use of separate transformers. An electrical engineer will perform a detailed load calculation to determine the total electrical load of the building, including the fire pump. The load calculation will take into account the demand factors and diversity factors of the various loads to arrive at a realistic estimate of the total load. The engineer will also perform a short-circuit study to determine the available fault current at the transformer. This information is needed to select appropriate overcurrent protection devices that can safely interrupt the fault current without damaging the transformer or other equipment. Overcurrent protection devices, such as circuit breakers and fuses, must be coordinated to ensure that a fault on the fire pump feeder or other building loads is isolated without causing a complete shutdown of the electrical system. This involves selecting devices with appropriate time current characteristics and settings. The engineer will prepare a coordination study to verify that the overcurrent protection devices are properly coordinated. If the existing transformer is not capable of handling the fire pump load or if proper overcurrent protection coordination cannot be achieved, a separate transformer will be required. The separate transformer should be sized to handle the fire pump load plus any other essential loads that need to be powered during a fire. The separate transformer should also have its own dedicated overcurrent protection devices. The installation of a fire pump and its associated electrical equipment must comply with all applicable codes and regulations, including the NEC local building codes and fire codes. The electrical engineer will ensure that the installation meets all of these requirements. It's crucial to consult with the local authority having jurisdiction to confirm any specific requirements or interpretations related to fire pump installations. They may have amendments or local codes that supersede or supplement the NEC. They can also provide guidance on the permitting process and inspections.